Hi everyone, how are you doing? Yeah, I don't know if watching The Matrix 20 times is an achievement, but I was a really big fan of those films when I was like 15 or 16 and had a bit more spare time then, and so you can really crank through the reps if you like a film. Today I'm going to talk about AI and the future of software engineering, and I guess most importantly, how we can be ready for it. A little bit about me. As you've heard, my name is Hywel. This talk is really at the intersection of two of my biggest passions. I think AI is great, and I think software leadership is both interesting and important. You've probably noticed, but AI is cool now. When I started doing machine learning and working in AI, it was back in 2007. I don't think my parents certainly wouldn't have known what AI or ML stood for at that point, and now these things are like headline news, right? Everyone knows about them. In 2016, I went to visit my old thesis supervisor, who's now a VP at Google DeepMind, and I wanted to get his advice on how I had a problem I needed to solve around small snippets of text and basically transforming them into something machine readable, and it felt like there should be an NLP kind of solution. And my old supervisor said, look, that technology just is not there yet. You fast forward to today, I don't think there's any question about whether that problem is solvable with AI now. The hard thing is actually working out how to get a short list of models to try. Is this making a weird noise, or is that my imagination? It is, okay. Well, I'll do what I can. We've just seen this massive leap forward in generative AI, and I think it's very cool. Like, I'm not alone in that, right? Like, other people think AI is cool, I assume? Okay, good. If you don't, like, this talk is going to be quite boring for you. I think AI can do surprisingly awesome things, like for a kind of a thing that is built to be naive about the world and to learn. It is kind of staggering how great it can be. Of course, it's trained on humans. Thanks very much. One, two, great. It's trained on humans, so it still has all the same kind of flaws humans do. A friend who is very into old music mentioned this character, Billy Shears. I thought AI can help me understand who Billy Shears is. Maybe some of you know already, I didn't. Billy Shears was apparently the replacement for Paul McCartney and the Beatles. And I thought that some people are laughing, right? Like, I didn't know enough to know that was an absurd suggestion. I thought I knew the names of the Beatles, but maybe there was one that I'd missed. I wondered why that was. The AI confidently told me that was because Paul McCartney died in a car crash in 1966, which I gather is not true from people who've been to Paul's concerts in the last 60 years. Of course, sometimes AI can be correct, but still be utterly useless. Now, you might have guessed from my accent, I'm from Britain, or as you call it, England. I don't know much about the American Constitution, but I would like to learn. This is something that AI told me, but I don't think it's that helpful. The American Constitution is not a valid JSON file. Your parser will reject it. I think actually America's founding fathers kind of missed a trick here. I think it would be really cool if all of the initial documents of a nation were in a machine-readable format. I'm actually working on a musical theatre production with that as the premise. H.G.M. Ellerton. Thank you. I appreciate you laughing at that. Like, believe me, this joke is entirely for my own benefit. I don't think anyone else should find this funny, so I'm grateful that you do. I think even when it's flawed, the potential for AI to transform what we do is really huge. We've seen the impact of automation before in terms of civilizations and society. We've had, by most counts, 4 previous industrial revolutions, and maybe AI will become the 5th. Each time, the pattern has been the same. There's been an increase in automation. Work has been significantly disrupted. There have been big changes in jobs and skills needed. But actually, in the long term, people still have jobs. There is still work to be done. The change is in what those jobs are. We need different skills, not fewer people. Now, when it comes to AI, I think some of the kind of societal upheaval is really well understood and widely discussed. These kind of social risks are all sort of front page news these days and are widely discussed even by non-technical people. I'm actually more interested in how AI plays out in software engineering. I think at the level of code, the risks and the problems are pretty well understood. The ability for it to improvise code, what some people call hallucinating, I think we know how to kind of deal with that. We know how to create checks and balances, just as we do with more junior new members of teams. We know how to deal with people who aren't writing code brilliantly yet. Security of generated code, again, there is a lot of existing experience we can lean on for solving that problem. It is a lot of trust to put in AI, but we are already comfortable with trusting humans. So if we can put the humans in a place where they can review the output from AI, we can kind of deal with this code level problem. And then IP ownership, again, well documented, all the kind of complexities around that. This now, I think, is largely a legal concern, one for our lawyers to tell us how we need to manage it. Personally, I'm more interested about our industry. What does software engineering look like? What do people's careers look like if AI continues on the trajectory that we're seeing today? Which raises questions like, what skills will future software engineers need? If we are able to generate significant volumes of code and that code works well, what skills do we actually need the humans around the code to have? How do our existing teams learn? How do we get new juniors into the industry in a world where writing code is not really our priority? How can we prepare now? What should we be doing? And then lastly, will software engineering jobs even exist? I personally think that they will, but there are some people who tell you that the entire industry is going away. And the most truthful answer anyone can give is we don't know for sure. But I'm not going to let that stop me having a go. I think we do know that juniors can't follow the same path as our existing teams, because that path probably won't exist. But I think we can try and answer these questions by thinking about what it means to write software today. So here's my approximation of the workflow of a software engineer. I'm sure this is not perfect. But generally speaking, people take tickets in some form. They plan a solution. They write some code and tests to create that solution. They get it functionally reviewed, make sure the thing they've built does the job, and then they ship it and monitor it. And we have plenty of feedback loops built into that system as well to make sure we build the right thing in the right technical way. I think where we see LLMs playing right now is very much that orange area in the middle, that writing code and tests. I'm aware that people are trying to use LLMs for other areas of this, or not just LLMs, sorry, but AI to automate parts of this whole workflow. Those things seem further away from being ready for mainstream use. Now, one of the things I find interesting looking at this is if you consider the ideas of Agile and the Agile revolution, there's kind of a pretty clear pattern here that those yellow areas there, the feedback loops and functional review, Agile was really about bringing those things closer to software developers, right? The idea of iteration, the idea of welcoming changing requirements, and bringing feedback loops closer to developers translates approximately to those yellow bits. And that bit in blue at the bottom, the idea of shipping and monitoring code, you can kind of see the DevOps revolution in that. The idea of ownership through to production, that we don't just, software developers don't just write something and then give it to someone else to run. So if we imagine a world where LLMs are getting better at writing code and tests, we as software leaders are going to want our teams to care more and be better at all of the things around that. Because suddenly we don't need people to write code and tests, but we need even more of the work that supports writing code and tests. We need people who can do all of those bits around it even better. If your team is not doing the bits in yellow and blue here, if you haven't really gone through that Agile and DevOps revolutions, there is a real danger that work looks more replaceable by LLMs. These bits in yellow and blue, I think, are fundamentally human. They require interaction with other humans, at least in the way we do them today. And therefore, those are likely to stay in the wheelhouse of the humans on our teams for longer. Where some developers really live in those top three boxes, right? Some developers like to say, I don't want to go too near to the user. I don't want to go near the kind of mess of running things in production. I want to take a ticket. I want to write some code, and then I want to go back to taking another ticket. I think those folks are in real danger. Those folks are going to look more replaceable than others. And so this is my kind of first conclusion about AI and the future of our industry. This idea of the just let me code mindset is probably not going to be sustainable for much longer, because just let me code is kind of what LLMs are starting to do super well. My own belief is that from here, we see AI improvement as many, many small steps. And don't get me wrong, we still get impressive results through lots of small steps and improving that way. I think the big leaps of improvement are going to be relatively rare. So while humans landed on the moon, with a number of small steps from there, we now have humans who can live on the International Space Station. But it's going to take some seriously big leaps before we get humans who are able to land on the sun. So I think we can look at what AI, that is an idea borrowed from Matt Blaze, by the way. If you don't know who Matt Blaze is, you should definitely look him up. He's cool. I think we can look at what AI does already and be confident in assuming that it will start to do those things very, very well and be brilliant at them where it's not already. I think we can ignore areas where AI isn't really doing a mediocre job yet. And so I would say we should be hoping for big leaps, because big leaps would be exciting and awesome. But at least in the near term, we can assume lots of incremental improvement and things getting better. Now, I talked a bit before about the workflow of developers. I also want to talk a bit about levels of abstraction, because I think while developing, we are used to our developers thinking at different levels of abstraction and considering those sometimes simultaneously. So we have to think about system architecture, how the entire thing is going to be built and what components we need. We have to think about the architecture of those components and what they each need to look like. We have to think about the interfaces between them and how different components are going to talk to each other. And then after that, we need to implement the components, and we kind of end up writing boilerplate, which is very much the easy, if somewhat time-consuming bit. Right now, I would say that LLMs that we're seeing are doing very well at creating implementations and are fantastic at writing boilerplate, which saves a lot of time. These other areas of, these other layers of abstraction, I think we haven't really seen LLMs enter into successfully, not in the same way as they have with the implementation and boilerplate bits. So from what I said before, I think AI seems to be particularly good at writing code. I think in the near future, we can assume that implementation, boilerplate, the writing code bits of this workflow will become near instantaneous, but probably not the idea of going from a ticket to planning a solution to writing the code and tests to doing some kind of manual functional verification that the thing works and then monitoring that in production. Doing that automatically without human input feels like a very big leap to me. And probably not architecting an entire solution and all of its components and their interfaces, or at least not as well as a human can. That's my belief in incremental improvement. And I appreciate that you might disagree. You might be more of an optimist and say, we are going to see the big leaps. And so you're probably sitting there thinking, okay, we are going to have all these big leaps. I think you're wrong. AI starts taking more and more of this work away from humans and can generate the architecture for us and do all of that thinking. So in that world, what's next? I think potentially we get entirely new programming paradigms where we don't have to think about code anymore because it's handled so successfully for us. We don't have to think about architecture because it's handled for us. And instead, we program almost conversationally. And then the job of our team is to be a kind of advisor or an edge case finder for the AI and to bring to bear the kind of contextual understanding we have of the problem that our code is trying to solve. So maybe in this world, we can just talk to an AI and say, I have this idea for a product. It's a social networking app, and people communicate by recording audio clips. Can you build that for me? And the AI just goes, yep, all right. I've architected it, worked out the components, implemented them all, built it. Here's a link. It's deployed. It's live. What do you think? Our job then becomes to kind of refine and give feedback and say, okay, the color scheme is pretty good, but you need to darken that red and like make the rest of the color scheme fit with that new color. And also I have this idea for a feature that I didn't tell you about before. And, you know, an intelligent enough human will ask the kind of edge case questions and say, okay, but how should that feature work? What should happen in this situation, right? That's the kind of the job of developers. Maybe AI can do the same thing and anticipate those edge case questions and then build those into the product it generates for us. And all we have to do is say, no, this is the requirement, and the AI builds it for us. I think this is a super exciting idea. I think a lot has to happen before we can have this, but imagine a world where the job of the developer is to express the edge cases, the business logic, just verbally, and the AI does the hard thinking for us of translating that into code. Whoever is right, whether it's the incremental AI getting better and better at what it does now, or the big leaps of AI taking over more of the workflow of software development, I think the conclusion is kind of the same. In the future, the job of humans is to be a reviewer, potentially at a very high level of abstraction, right? Maybe we're reviewing the entire application and searching for those edge cases and business logic ideas and telling the API what the right answer is. And maybe we're reviewing implementation and boilerplate at a much lower level and just guiding the AI about the right thing that we want to build and what the interface should be and what the component needs to achieve. We need devs to become the editor rather than the author, the curator instead of the artist. And so I think this is probably what a future of AI-enabled coding looks like. Everyone becomes a reviewer. And if you're more skeptical about AI, that means reviewing the generated code. And if you're more of an optimist, that means reviewing the application and thinking about it from a technical perspective. Now, this lets us refine those questions I had about the future. So instead of just asking very broadly what the future looks like, now we can say, well, how do our teams become those architects or reviewers without being developers? If they're not writing code, how do they achieve that position? How do we get new juniors and progressive? What even does a junior architect or a junior reviewer mean? And then how do we keep our talent strong? How do we keep the skills they have high if they're not solving problems with code anymore, especially considering how fast things typically move in technology? To answer that, I'm going to refer to Bloom's taxonomy. Bloom's taxonomy, if you haven't seen it before, this is about the outcomes of learning. The idea is it is in layers that build on each other. No, there's no laser on here. So essentially what it says is that knowing is a requirement for understanding. Understanding is a requirement for applying. If you can apply, you might also be able to analyze and work out how to apply in a given situation. If you can do that, you can evaluate and look at something someone else has done and say whether it's done well or poorly. And then above that is create, being able to do entirely new kind of original approaches to solving problems. One of the things this tells us is that you have to be able to apply in order to evaluate. You have to do in order to be able to review. And currently our model for software developers is to learn by doing. So how do we climb this? How do we get software engineers who are good at evaluating, reviewing code or products that are generated for us if we are no longer applying and writing the code ourselves? Certainly, I think something will have to change. We can't expect people to learn by osmosis from their peers as a side effect of being on the job, because their peers aren't writing code anymore in this future. Also, I think this is the bad old way. Relying on informal learning has never been a great way to do things, because the people who rise to the top are the ones who have the time and the resources to pursue learning independently. And it also gives opportunities to people who are more likely to gain the favor of mentors. And typically speaking, mentors choose mentees who remind them of themselves. And so this has always kind of historically been a self-reinforcing, anti-diverse cycle that's part of the status quo that I don't think is a good thing. I talked a bit about conversational programming, the idea of having an AI-enabled new layer of abstraction in how we think about programming that sits on top of existing languages and technologies that we have. If you think about a strong Python developer now, they probably know Python really well, but they might also have a strong understanding of languages the next level down, some low-level languages. Maybe they need to understand memory management from time to time. And they probably also have an understanding of hardware. Maybe they need to know like the throughput of memory buses into a GPU, right? Like clearly that's relevant for some people. Like that understanding as a developer is something that people are getting while they're writing Python. They are learning those things without writing the code in those languages. My prediction is that in a world where we are no longer writing the code ourselves and we are instead reviewing at a higher level of abstraction, we still need to understand the levels below that, just as that Python developer does now, we still need to understand the other levels of abstraction to be able to be effective at reviewing at a higher level of abstraction. So how do we get there? How do we get to a point where we are good enough to review code without actually writing code? Because I don't think we're in a situation where this industry disappears, but we do need to evolve. New folks won't be learning by doing, and existing folks won't be staying sharp by doing. I think what this means is an increased focus on structured learning. I think the ability to learn is the key to getting through any period of significant change and disruption. Every industrial revolution we've seen in the past, people lost their jobs and then gained new ones which required different skills. So I think the ability to learn becomes our strongest predictor of success in a world where AI eats away at what the typical work of a software developer is. And I think it's going to be necessary for our teams to stay relevant. So rapid effective learning is how you can stay ahead and even accelerate. I think it's very cheap for me to just say, hey, everyone, learn better. So concretely, I would like to give you some ideas for what you can do differently when you are back at your desk, that you can hopefully shift your thinking a little bit. Firstly, let's bin the idea of best practice. Let's just get rid of that. Best practice is a kind of cheat code to the right answer. If people start talking about best practice, it misses the conversation about why something should be done. It's like a conversation ender rather than an opportunity to learn. If people are going to learn, they need to know the alternatives and why a decision is made a certain way and what the reasons are and the thinking behind it. And this is a great way to encourage learning very easily, actually. If you just ban the phrase best practice and people start asking why, they will start learning. The idea of it works, but I don't know why. I think there are lots of people who already see red flags when they hear that phrase. We should be concerned. The idea of not knowing why something works or how it works is very dangerous. It means we can't be confident that it will continue to work tomorrow, and tomorrow is not very far away. Confidence is required for us to have robust code, but it's also this also is an opportunity for learning, right? If people aren't allowed to get away with without understanding why something works, they will learn why it works. And that helps to prepare our team to be ready to probe code that's generated for us by AIs. Learning is a side effect. So I think this is learning that is a side effect of working, the kind of slow, serendipitous, almost random, the thing that comes up in work is what I am learning today kind of learning. Learning really matters. And it's only going to matter more. So I think we need more formal, structured learning to find and fill gaps in our teams. And then lastly, passive learning needs to be replaced with interactive learning. The status quo for structured learning looks like reading a book or watching a video lecture, which is passive. It's widely understood to be the least effective mode of learning. There are still benefits to it. There are still benefits in people feeling getting exposed to new ideas. But in terms of being able to do something, what you really need is expert-led, hands-on environments, what's called interactive learning, where you are learning by doing alongside other humans for teams to stay on top of their game. Just briefly, I work at Hywel. I founded it because I wanted learning that could make my teams ship better code faster. I couldn't find it, so I built it. If this talk is interesting to you, or if any of the ideas have stimulated thoughts, or if you just wildly disagree with me, I would love to talk to you more. I'll be at the AMA area outside, or you can come and find me at the Hywel booth, which is kind of back by the entrance in the main hall. Please do come find me and say hi, and thank you for listening.